I want to explain what is software architecture in this video. When people say software architecture, different things come to different people's mind. Some people might think that it is diagrams, boxes and arrows, but it is not software architecture. We may use these things to represent a software architecture, but these on its own is not software architecture. One definition that I like to define software architecture is this one. It is enduring structure and constraints that gives the system its shape. This is my preferred definition of software architecture. I know this is very abstract and there are a lot of keywords in it. Let's break this down one by one. Let's start with enduring. Software architecture is enduring. Why it is enduring? It is because even when the code, library or the framework or even the team that developed that software changes, the architecture remains the same. So this is why the architecture is enduring. So if you take an example of an order service and it is developed using .NET and it is developed by team A, for example, for whatever reason, we have decided to rewrite this. We have decided to rewrite this order service in Golang and it is going to be rewritten by Team X this time. And the order service developed by Team X using Golang is going to be exactly same service as the other service that we previously had. And it is not going to have any contract or interface changes. But the technology itself is different and it is developed by different team. Even in this case, because the order service remains the order service, the architecture remains the same. Regardless of different language and different team, the architecture stays intact. It has no impact. So this is an example where some of the non-architecturally significant things are changing, but still our architecture remains unchanged. So this is why architecture is enduring. Next, let's look at structure. So we saw that we have structure and constraint that are enduring, which defines the shape of the architecture, right? So what is structure? One way to think about structure is that it is a way to organize responsibilities. So we'll have different responsibilities within our system. We somehow organize them. Usually we'll have different parts within the system and each of those parts will have some responsibilities assigned to them. So that is what defines our structure. So we may have something like API gateway. API gateway is responsible for security policies and rate limiting, for example. And we may have another part within the system called order service, and this may be responsible for order and inventory management. And we may have another part like payment service, which may be responsible for payment and refund. Here, payment service cannot do security policies and rate limiting. Likewise, API gateway cannot deal with payments and refunds. Okay, so we have clearly defined the responsibilities for each parts of the system, and these parts are called structure. So we'll have responsibilities within the system and we will assign those responsibilities to different parts within the system, and those parts are basically the structure. The next one is constraint. We saw that architecture is also about constraints. Constraints are basically rules that our system forces on us. An example for this would be like a service cannot access another service's database directly. So we may have a system like this where red system has its own database and blue system doesn't have its own database, but it needs some data from the red system. So if the blue system accesses the data directly from red system's database, then that is not correct because our constraint says that this is not allowed. So we will stop this from happening. We will force blue system to use APIs exposed by red system to access the data. So these type of constraints are also part of architecture. Another example is we may have communication among different services only using synchronous request response pattern. This may be one of the constraint. If this is the constraint, then if we have system like this, where we have these two systems are communicating with each other using REST API, which is synchronous request response pattern, this is allowed. But if the communication between these two systems are established using events using some sort of service bus or something like that, then that is not as per our constraint. Our constraint explicitly says that the communication between the services has to be synchronous request response pattern, and event based communication is not one of them. So this is violation of that constraint. And another example is like, we can say that all the requests coming to our system has to come through an API gateway, because we may have some policies and rate limiting there. So we want to force all the incoming requests to come via the API gateway. So this is another example for constraint. Next one is shape. Shape is basically what we will get by combining the structure and constraints. So if we imagine that we have system with many parts, and those parts are these red boxes, these are basically the structure, and we have arrows between these boxes. These arrows define what kind of interactions are allowed between these parts and which part can talk to which other parts and stuff like that. So the structure and constraint like this provides the shape of the system. Even if we zoom out and ignore all the implementation detail, this level of information remains intact, right? So we'll have boxes and arrows going between those boxes. Those boxes represent structure and the arrows between those boxes represent constraints. So this is what we call as shape of the system, and we get this by combining enduring structure and constraints. Now, another way to look at architecture is basically it is decisions that create lasting constraints that matters. We make some decisions, those decisions creates our structure and constraints, and that shapes our system. So that is another way to look at the architecture. Now let's look at some examples of what kind of decision become architecture or help to shape the architecture of the system. So if we have things like how system is deployed, if we have made a decision on how system is deployed, then this is one example of a decision that defines the architecture. And another example is who owns the data. So if we have some data, we have many parts within the system, which parts own the data? That is another example. And if we have defined how our system scales, and if we have defined how different parts of the system communicate with each other, these decisions are architecturally significant and these decisions shape our system. So we make decisions and those decisions shape our system. These kind of decisions are architecture. Usually, if a decision is architecturally significant, then it can't be rolled back within a sprint. If you can roll back something within a sprint, then it is probably not an architecture or architecturally significant decision. Now let's see some examples of what is not an architecture or what decisions are not part of an architecture. Usually choosing a programming language, choosing between C# and Java is not probably an architectural decision. And choosing a framework like Angular over React is probably not an architecturally significant decision. And choosing a database is also not architecturally significant decision. I just want to clarify here that the type of database that we choose, whether we choose SQL database or DocumentDB or Graph database, so these type of decisions are architecturally significant. So these matters. But once we have decided that we want to go with, for example, SQL database, then choosing SQL Server over Postgres over Oracle is not architecturally significant decision. These things matter. I'm not saying that choosing a programming language or framework or database doesn't matter. These things matter, but these are not architecturally significant. Even if we choose C# over Java or Angular over React, the architecture remains the same. It is not going to have significant impact on the architecture. So basically the architecture survives. But in some cases, choosing a particular technology may have impact on the architecture. For example, if you are choosing JavaScript as a programming language, then JavaScript only supports single-threaded asynchronous programming model. So if that is architecturally significant, having multi-threaded programming model is architecturally significant, then choosing a programming language or framework is architecturally significant decision and it matters. But most of the time, programming language, framework and databases are not architecturally significant and they won't have significant impact. So I just want to repeat again that architecture is enduring structure and constraint that gives the system its shape. So this is the definition I prefer for software architecture. That is all I wanted to talk about in this video. I hope this is useful. Thank you.